So we are still looking at lipids. So we've looked at fatty acids. We said they can be saturated or unsaturated. Now another property of fatty acids that you need to know is that they can exist with the cis or trans. They can exist in cis or trans forms. Okay, fatty acids, they can exist in cis or trans forms. So perhaps you don't know about fatty acids, you can refer to the second video on lipids. Now, what do we mean by fatty acids existing in cis or trans forms? Remember, for you to have the cis and the trans form, you should refer to unsaturated fatty acids. Unsaturated fatty acids, these are fatty acids which contain a double bond. Okay, a double bond. So when you have got like the, remember, if you have got something like this carbon requires two hydrogens to be stable. So if you have got a hydrogen here and a hydrogen here, even this one, the hydrogen here, the hydrogen here, you are going to call this as cis because the hydrogens are on the same side. But if you've got the trans, you're going to see one hydrogen is on top, another one here, and then for this other one, the one hydrogen is like down there, you see. So the hydrogens are on two opposite sides. You're going to call that a trans. So you understand this more in organic chemistry when we talk about cis and trans isomerism. Just know that trans is opposite sides and then cis is same side. Okay, so we are now going to understand, we're going to look at now glycerol as another example of lipids. Glycerol. Okay, now really, what is glycerol? So glycerol, you need to know the other name for glycerol is glycerin. Okay, like that thing that we, that I don't know if I can call it lotion which we used to drink when we are children. Glycerin. So that's the other name for glycerol. Okay, so that's the other name, glycerin. Now, glycerol is a simple sugar polyalcohol. Please, from just now, know that it is a simple sugar polyalcohol. All right, so that is glycerol, a simple sugar polyalcohol. What do we mean by polyalcohol? The functional group for an alcohol is the hydroxide OH. It means it has got a lot of OH groups. That is what we mean by polyalcohol. And if you think of it, like if you get glycerin, you try to taste it, it is sweet, right? So it is more is a sugar like that. You are going to understand more. Okay, now how do you get to make glycerol? Like, okay, not really making it, but how is glycerol? So glycerol is when this glycerol which you have here gets to react with the fatty acids which you saw. Now that reaction, we're going to talk about it later, but you need to know just from here that when glycerol reacts with fatty acids, you are going to form glycerides. Okay, you are going to form glycerides. Now we're going to understand those later. So now the properties of glycerol, I think you even know from glycerin. The glycerin we know, they are colorless. Glycerol is colorless. It is also odorless. It doesn't have any smell. Okay. It is also viscous. In other words, it's a bit sticky, and it is also sweet. That we know, right? So these are some properties of glycerol, which is called also as glycerin. So it has three hydroxyl groups. Remember when I was teaching carbohydrates, when we were looking at monosaccharides, we talked about trioses. Remember, I said that there is one triose which is, the trioses are confused with some lipids, and actually trioses are confused with glycerol. You are going to see. Okay, so glycerol has got three hydroxyl groups. So the formula for glycerol is C3H8O3. Now remember, for the trioses we said their formula is C3H6O3. This question comes as a multiple choice. I'm going to bring the formula. You identify whether it is glycerol or it is a triose. They will bring maybe this formula. They say identify this formula. They are going to put glyceraldehyde, they are going to put glycerol. Actually, that is why we call that triose glyceraldehyde, because it is more similar to glycerol in structure. But the only difference is that glycerol contains 8 carbon. So the way you're going to see this one, I'm going to write it. You are going to have first, I mean, it has got 3 carbons and 8 hydrogen. So 1 carbon, 1 carbon, 1 carbon. So these carbons are going to be attached. First, you remember we've got 3 oxygens. So we're going to have oxygen always bonds with an hydrogen. This one also, this one also. Now remember, this is what we said. Like, this is how most of the carbohydrates are, right? That is why this is a sugar. Okay, and then the other hydrogens which remain, they're going to attach like that. So this is the other hydrogen. So this thing you're able to see here is glycerol. But when you are talking about dihydroxyacetone, or not dihydroxyacetone but glyceraldehyde, it also has got 3 carbons like that. Okay, but the first carbon is going to have a functional group. Okay, and then you are going to have one hydrogen there, and then this is going to be OH, this is going to be OH, this is going to be an hydrogen, this is going to be an hydrogen, this is going to be an hydrogen. So this is the difference between glyceraldehyde and glycerol. What is the difference? The difference is just you having an aldehyde functional group. That is what makes it glyceraldehyde. That is why it is even glyceraldehyde. Okay, one has got 6 carbon hydrogens, the other one has got 8 hydrogens. Hope it is clear. Yes. Pardon? Yes. So for the glyceraldehyde, it has got a carbonyl functional group, and also you've seen these are also hydroxyl functional. So it has got hydroxyl functional groups and a carbonyl functional group. But this one only has hydroxyl functional groups. So that's another difference. Okay. So this is glycerol. Okay. So the other name, now you saw the structure which I drew. Now most we are going to see this drawn as in skeletal form. So I'm going to draw this. I'm going to put 3 like that. This is going to be the OH. This is going to be the OH. This is going to be the OH. And then this is going to be hydrogen, 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 hydrogen. If it was glyceraldehyde, it would have been a double bond with oxygen there, and then it would be OH, OH, and then the rest are going to be hydrogens like that. So that's the difference. Okay. Now, the UPAC name that we can give to this one, when we are naming them using organic chemistry, you are going to understand how to name them. We actually also call this as it has got how many carbons? 3 carbons. And an organic compound with 3 carbons, if you remember from high school, that is called prop. 2 carbons is called the F. 1 carbon meth. That is where the methane comes from. Ethane, propane, butane. So 3 carbons made prop. So it came from propane. Okay, it came from propane. But because this is an alcohol, you remove the E at the end. And then I'm going to put a dash. Where are the functional groups for the alcohol? We have got at carbon number 1, carbon number 2, and carbon number 3. So I'm going to say propane 1, comma 2, comma 3. And then at the end, how many are there? There are 3. We are going to put tri, and then you put the O. So that is the UPAC name. Propane 1, comma 2, comma 3, tri O. Or you can say 1, comma 2, comma 3, propan, propan, tri O. So that is just the UPAC name. Maybe for example they get to bring that. Just know that propan 1, comma 2, comma 3 tri O is glyceraldehyde. Okay, so having understood that, you need to know glycerol. I mentioned glyceraldehyde, please. Propan 1, comma 2, comma 3 is not glyceraldehyde, it is a glycerol. So it is, this compound is an important component for natural lipids which are called glycerides. As I said, we are going to understand how we make glycerides. So this is an important component of glycerides. Okay. Now when this gets to react with some acids like fatty acids, you are going that will be an esterification reaction. You're going to understand that. Then you are going to form glycerides. So it is produced from the lipid through saponification. The glyceride I'm talking about, it is produced through saponification. Saponification is a process of making soap. We are going to understand when we get to do that. Okay. So what do we need to know apart from that? So these are some things that we need to know. Okay, these are some things that we need to know. Now the glyceride which we are going to talk about, that is formed from glycerol. So we are saying glycerol is important in the production of glycerides. Now these glycerides are very important. Why? They are used as solvents in the industry, like to dissolve organic compounds. Apart from that, they are also used as sweeteners. Okay, they are used as sweeteners. They are also used as preservatives when you want to keep like things, when you want to preserve things. Apart from that, they are also used in pharmaceutical purposes. If you talk of pharmaceutical purposes, this has to do with medicine. Okay, it is used for pharmaceutical purposes, and it is also used in cosmetics, like the formation of soaps and like things like shampoos, creams, those things. Okay, so it is used in pharmaceutical purposes, like in cough mixture. Okay, when you have got a cough, so this is part of that medicine that is there for cough, like to help you in a cough. It is also there for skin products, like in cos we know cosmetics, even skin products. When maybe you've got some skin problems, this is also very important. All right. Now that we have understood glycerol, we need now to know glycerides because they come from glycerol. Okay, glycerides. Now, when you are talking about glycerides, glycerides are basically esters. Okay? Remember, an ester is a compound that is formed by esterification. And esterification is just a process by which an alcohol reacts with what? An acid. Okay? So a glyceride is basically an ester, and it is formed by esterification when a fatty acid reacts with the glycerol. So this is a reaction that gets to form glycerides. Now, how does this happen? Remember, we talked already about a fatty acid. How is a fatty acid? We have got OH here. We have got OH there. We have got OH there. Okay, this is glycerol. This one I'm drawing is glycerol. Okay, like that. And this is going to react with, actually, it doesn't just react with one fatty acid, but three fatty acids. Okay, one glycerol reacts with three fatty acids for it to be able to form uh, what we are going to call as a triglyceride. But okay, before then, let's get glycerol. Now, I've already written glycerol here. Now let's get a fatty acid. Remember, we said the fatty acid is made up of what? A lot of carbons, and at the end we are going to have what? We are going to have a carboxyl functional group. So we're going to have this chain. Like that. It's a long chain. Okay, it can have 16 carbons. It can have 18 carbons, like in oleic acid. Okay, you also have linoleic acid, which has got 18 carbons, but there is just a very small difference. So what you're going to see is at one end you have got the functional group, a carbon double bonded to oxygen and an OH. This is the functional group, right, of a fatty acid. So what is going to happen is that this functional group gets to interact with this functional group, which is here, and that is going to form water. So this reaction is what? This reaction is uh, a condensation reaction or dehydration. Now, I didn't mention lipids do not have monomers. Lipids do not have polymers. You can see we don't have like a very small molecule that is reacting with another small molecule, forming a very big molecule, a lipid. No. We basically have different substances. That's why we say lipids and do not have monomers and they do not have polymers. Like monosaccharides are going to have small units giving you a big unit. Proteins are going to have small amino acids giving you polypeptides, but that's not the case for lipids. Okay, so when you have got one fatty acid and one glycerol, yes, Martha. Yes, they are going to have an oxygen bridge. That is an ester bond. So what you are going to see is this hydrogen is going to go with the OH which was here. Okay, those are going to go. So what you are going to see is, let me try to pull that. What you are going to see, a bond that is going to be formed is going to be like this. An oxygen is going to be linking. This is called an ester bond. An ester bond. So when you have got one fatty acid which has reacted with a glycerol, this is going to be called a mono. Okay, because it's just one, so this is going to be called monoglyceride. If you bring again another fatty acid there, okay, another fatty acids, there are now two, it is going to be called the diglyceride. If you bring another fatty acid, there are now three, that is going to be called a triglyceride. So depending with how many fatty acids you have, that is what is going to determine whether it's going to be mono, di, or triglyceride.